All right, so in this example, we're actually going to be given a whole bunch of different types of sentences, and it's going to be our goal to actually identify whether or not these things are in fact statements. So if you go back and remember what this idea of a statement's all about, a statement is simply a declarative sentence that has this really special property that is either going to be true or false, but not both. There's none of this kind of wishy-washy middle-of-the-ground stuff. There's no kind of external variable that can change along the way to sometimes make that thing true and other times make that thing false. And that's really going to be the thing that's going to be on our radar of kind of problems that are going to break some of these mathematical expressions is, am I leaving something unidentified? Have I not declared one of my variables? So for those of you in the computer sciencey world, think about this as I need to initiate my variables. I need to tell you what kind of world I'm actually going to be living in. So in this first sentence, I'm going to have this expression that says 3 squared plus 4 squared is going to equal 5 squared. So on the outset, if you look at this thing, you can see that I actually don't have any variables in play. So there's none of this kind of something that's going to be left unidentified. This is going to be a very nice statement. It's going to be either true or false. I could actually dive into this thing and go ahead and compute all of those kind of expressions to see if it is in fact true or false. And if you do this, you can see that taking 3 squared, adding another 4 squared, those two things added together are going to give you 25, which is exactly what 5 squared is. So in this case, it is a statement, and moreover, it's actually going to be a true statement. So for now, I'm just caring about identifying it as actually being a statement. If you look at that second example, example B, well, now we're at this situation that I have an A and a B and a C kind of floating in this picture. And here's where the problem's going to come into play, is that I've not told you what A, B, and C have to be. If I take A, B, and C to be 3, 4, and 5, you can see that that sentence is going to become true. However, if I take A to be, let's say, 0, and then B also to say, let's say, 0. But if I take C to be 1, well, in that situation, it's going to simplify to saying 0 equals 1. And in that particular instance, that thing is going to be false. So here's where I have that little wishy-washy middle-of-the-ground stuff. In some situations, like 3, 4, 5, it's going to be true. But in other situations, for example, 0, 0, 1, it's going to be false. So in that situation, it's not that kind of nice cut and dry stuff. I've not actually identified what A, B, and C have to be, so it's going to not be a statement. All right, so let's look at that third one then. So the third one's actually going to be piggybacking off of the first two examples. What I'm going to be doing in this situation is I'm kind of starting off this sentence with this expression that says there exist integers A, B, and C. In this case, it's going to be very similar to a declaration of what types of variables am I going to be playing with. In this case, I'm telling you that I'm working with integers A, B, and C, and the idea is that I'm going to be looking for a very special triplet of these things that is going to have this property that A squared is going to equal B squared plus C squared. In this situation, I don't have anything unidentified. I know everybody in play, so this thing is in fact going to be a statement. And in this case, it is actually a true statement. I've actually switched around my equal sign with a plus sign. So in this situation, you can actually go ahead and find an example. For example, 5 squared is going to equal 3 squared plus 4 squared. Basically, any of these kind of Pythagorean triplets that you'd want to, you kind of see is going to pop up into that thing and actually give you that that thing is going to be a true statement. But for now, it is just kind of a statement. That's all I really care about. Okay, so now let's go ahead and look at D. D is actually going to be a subtly kind of sneaky one. On the onset, it's going to simply say if x squared equals 4, then x is equal to 2. So you might be tempted to say that that thing is actually a statement. However, this thing is not going to be a statement for the same reason that part C or part B was not a statement, is that I've not actually identified what this x has to be. On one side, I could say x should be some type of positive number. So in this case, if the universe I'm living in is going to be x being positive numbers, well then if I have x squared equals 4, if I take the square roots of both sides, I do see that x should be 2. And in that case, I'm going to have a true statement. However, if my universe that I'm living in is only talking about negative numbers, well then in that situation, if x squared is going to equal 4, taking the square root of both sides, that's going to kick out a negative 2. So you can see that in those two different situations, one time I have a true statement, and the other time I have a false statement, and there's that little bit of wishy-washy stuff in the middle, and I don't really like that. So I've not actually identified what those x's are, so in that situation, I'm going to have something that is not a statement. And the problem is that I'm missing that little kind of front matter stuff. I'm not really initiating what's going on. So the way that we fix these types of things is by introducing these different types of quantifiers. And in chapter 2, we're actually going to be diving far more into this notion of quantifiers, is really kind of identifying what variables are in play and things like that. So in this situation, if you go ahead and tell me that everything is going to be in play is going to be a real number, I no longer kind of have this question of doubt of where these x's coming from. In this case, I know that all of my x's are going to be real numbers, and then I'm going to enter this kind of sentence that's going to say if x squared equals 4, then x equals 2. And in this situation, it's actually going to be a false statement. for the reason that we mentioned up above. If x squared is equal to 4, what's going to happen is that x could be either 2 or x could be negative 2. So in this situation, because I'm allowing any possible real number, I know that this is actually going to be a false statement. So you can see the slight difference between those two things. One of these I've actually given myself a giant, nice universe to be working with, whereas in part D, I didn't have that universe. I had no information on where x was coming from. Like I mentioned, if x is just talking about positive things, that sentence would actually be true, and if x was just talking about negative things, that sentence would have been false. Okay, so these last two things are actually going to be statements as well. There's nothing left to kind of doubt what's going on in this situation. There's no mystery x's or any of that kind of stuff. The first one's going to simply say every rectangle is a parallelogram. If you go back to your days of geometry, hopefully you'll remember that that thing is actually a true statement. There's no question of doubt of where all these things are living. And the very last one is actually kind of a fun little one in that it is one of these things that actually we have no idea of how to determine if it's true or false. It is one of these things that is a very big open conjecture. Actually, if you can prove part G, you actually could win $1 million. It's one of these very fancy Clay Mathematics Institute problems called the Goldbach conjecture, which if you happen to solve, you can win $1 million. So there you go. Actually, I think it's probably up to $2 million now. I think it was one of these ones that were left open for long enough that they decided to double the prize money. But in this situation, just like up above, there is nothing open. Everything has actually been identified. I'm going to be dealing with natural numbers. They're going to be greater than or equal to 4, and they're going to have some specific property going on. There's no kind of cast of doubt of who's in play in this particular situation. So that's really the type of thing you're going to be looking for in the world of whether or not something is a statement. If something casts some amount of doubt on who's in play, for example, these open variables occurring, if you have those types of things, you're going to be dealing with something that is not a statement.